Hi there! Today I'm going to show you how to create an implementation of the game Connect 4 using Phaser 3. This video is part of our game prototyping with Phaser 3 series, and the goal of this series is to create a very basic implementation of a game to get the high level functionality of the game down with the basic game elements. And then you would take that game on your own further in order to create a fully fledged game. So on the screen here, we can see an example of what we'll be building in today's video. Alright, so in the game of Connect 4, your goal is you want to connect 4 of your game pieces together in order to win the game. And so how the game works is you want to go ahead and try to get your game pieces either in a row, a column, or diagonally in order to win. And how the gameplay works is in the board game, the player is going to drop a game piece in at the top of the game board. It's going to fall all the way down to the first available space. So as an example, as player 2, if I drop a piece here, it's going to go ahead and drop from the top and come all the way down here. And then likewise, if we keep adding these pieces, eventually that column is going to go ahead and fill up. And then eventually the player will win the game once they get those 4 in their row. And so just as an example, players can also win by getting their pieces connected vertically and diagonally. So one thing to note is we will be using an NPM package to go ahead and build out our game of Connect 4 for our prototype. In this package, it has all of our core logic that we need for creating a Connect 4 game instance and for handling player input and for checking for wins, draws, and invalid input. So for this video, we won't be going into the core logic. However, in a previous series, we went ahead and we built out this NPM package together for this reusable library. So if you are interested in learning more on how to build that reusable library and for understanding the core logic of Connect 4, I do recommend that you check out this series. There'll be a link on the screen now to this playlist, as well as in the description of this video, there'll be a link to this playlist. And so before we dive into our code, we're going to go ahead and review what tasks we'll need to complete in order to create our game prototype. To get started and to follow along with the code, you will need to go ahead and download a new instance of our basic Phaser 3 TypeScript template. In the description of this video, there will be a link to download this template from GitHub, and in a previous video that I'll be sharing, I discussed how we would be using this template in our video series on creating game prototypes with Phaser 3. There'll be a link on your screen now, as well in the description of the video, and in that video I cover where you can find these project file templates on GitHub, how you can download and set up the project locally, how you can go ahead and install the project dependencies and then run the project locally, then view the Phaser 3 game locally on a dev server. We then reviewed the project structure and talked through the underlying code that makes up the basic Phaser 3 game. If you're interested in learning more about this template, I definitely recommend checking out that video now. So in this video, we will not be reviewing the project template or how to run the project locally. Once we get to the coding section of this video, we are going to jump right into the code. So in order to create our Connect 4 prototype, we'll need to complete the following task. The first thing we'll need to do is we'll need to go ahead and download the assets that are used for this project. And so for our game prototype, we'll be using one sprite sheet, and that's going to have all of the sprites that we'll need for our game. Once we do that, we're going to go ahead and update our game configuration for our template to match the Phaser game configuration that we need for our game. And so we'll be doing things like modifying our canvas width and our canvas height. Once we update our configuration, we're going to go ahead and install the Connect 4 NPM package that we'll be using for our game. And so this package is going to have our reusable library that we've built before, and it's going to have all of the core logic that we need for our game. Once we do that, we're going to switch to our Phaser code, and we're going to go ahead and start loading in our game assets. So we'll go ahead and load them in so they're in our cache, and we can use them in our scenes. Once we do that, we're going to start creating our Phaser game objects. And so we're going to create our board layout. So we have our 7x6 grid that we need. So once we have our board layout, we're going to go ahead and start adding a logic for handling our player input. So this is going to involve code like listening for hover events when our mouse hovers over one of our columns, or when we click on one of the columns in our row, or when we click on one of the columns in our board. And then we'll go ahead and add our logic for having our game pieces appear based on those click events. We'll also go ahead and add in our text for our UI so we know which player's turn it is in our game. And so once we have that, we're going to go ahead and connect this to our Connect 4 library. And then we're going to go ahead and add in logic for handling when our game's over. So then that way the player can go ahead and restart the game. We'll display the winner in the scene. And then we'll give the player the option to go ahead and reset so they can start the game all over again. All right, so the first thing we need to do is we need to go ahead and download the assets that we'll need for our project. So we're only going to have one asset for our game. It's going to be sprite sheet here that's going to have our board background as well as our yellow and red game pieces. So in the description of this video, there's going to be a direct download to this image from GitHub. And you'll need to go ahead and download that image, and then that way we can load it into our project. And so what we'll want to do is we're going to place that image in our public assets images folder, and we'll just have it called Connect 4 PNG. All right, so the next thing we're going to do is we're going to go ahead and work on updating our game configuration. So to get started, we're going to go ahead and jump into our source and then our main.ts file. And what we're going to want to do is we're going to update our phaser game configuration here. And so what we're going to go ahead and do is we're going to update our game width and height. So then that way we can resize our canvas to our appropriate size for the game we're building. All right, and so for our game size, what we're going to go ahead and do is we're going to go ahead and make this dynamic based on our sprite sheet that we're using. And so what we need to do for our game is we need to create a 7x6 grid based on these assets here. And so we need to figure out how many pixels each of our sprites is going to be, and then use that to calculate our board. What we're also going to do is we're going to go ahead and scale up our game a little bit, because if our game was this size, it's a little bit small. So we're just going to go ahead and double the size of our sprite, so then that way it just looks a little bit bigger. So to go ahead and do this, we're just going to add some variables to do all these calculations. And so the first one we're going to do is we're going to do const, and we're going to do scale size, and we're going to go ahead and set that equal to 2, so we can just double the size of our sprites. And now we need to keep track of our frame size, and so we're going to do const, we're going to do frame size, we're going to set that equal to 32. And now we want to go ahead and calculate what our scaled frame size is. Let's do const, and we'll do scaled frame size. And that'll be equal to our scale size times our frame size. And then what we're going to go ahead and do is we're going to go ahead and calculate our game in width now based on the scaled frame size. Let's do const, we're going to do game height is going to be equal to our scaled frame size times 6. And then we do our width, so we'll have const game width. We're going to set that equal to our scaled frame size, and we're going to multiply that by 7. And so the reason we're doing this is it just makes it a little bit easier to scale up our game and modify it instead of having to hard code our pixels width and height right here. And then that way later on, if we ever want to support things like a different board size, like maybe a 5x5 or 10x10, all we need to do is come in and modify these values up here, and then our canvas is going to go ahead and get updated based on these values here. And now let's want to go ahead and update those values in our game configuration. So if we copy our height, we'll go ahead and place it on our height. Let's do our width. And so now when we save, our canvas should now be updated to reflect those sizes. All right, and so one other change we're going to do is we're going to go ahead and add a div just so we know what game we're playing, and we're going to add some CSS to our HTML page. So what we're going to go ahead and do is we're going to go ahead and open up our index.html. And let's go ahead and add in a div so that way we can at least have the text of our game up here. And so what we'll do is under our container div, we'll go ahead and add a new h1 tag, and we're just going to say phaser3, and we'll say connect 4. All right, so after adding that h1 element, we see our styling is a little bit messed up. So what we're going to do is we're going to go ahead and use flexbox to go ahead and align some of our items on our page. And so to do this, we'll keep our existing CSS, and then we're just going to go ahead and add the display property, and we're going to go ahead and change this to flex. So then what we can do is set our flex direction, and we're going to do a column, which is just going to line up our items top to bottom next to each other. And then what we're going to do is we're going to do align items, and we're going to do center, and then that way our items should be centered. And so now because we're using our CSS here to align our items, what we want to do is come back to our phaser game configuration, and we're going to go ahead and get rid of auto center because that's going to modify the centering on our objects as well. So once we have those changes, we'll see now our game looks like this. All right, the next thing we want to do is we want to go ahead and install our npm package for our Connect 4 game. So what we want to do is we're going to go ahead and use this npm package that we previously published for Connect 4. And so go ahead and install this package. What you want to do is go ahead and navigate to your terminal. All right, so for installing our package, you can use any package manager that you would like. I'm going to go ahead and use Yarn, but you're welcome to use npm as well. So I'm going to go ahead and do yarn-e, the package, and then I'm going to go ahead and pin our version. And the version we're looking for is 0.0.5. And so now if we go ahead and install our package, it should go ahead and install that into our project. And now if we go ahead and jump over to our package.json, we should see that our package has been added to our dependencies with our appropriate version. So next, we need to go ahead and load in the assets for our game. So if we jump back to our main.ts file, what we'll want to do is we need to go ahead and load in our assets in our preload method for our scene, and then that way we will have access to them in our create method. So to go ahead and load in our assets, I'm going to go ahead and make a variable to store our asset key. And I'm just going to do const. I'm going to do asset key. I'm going to set that equal to sprite sheet. And so the reason I'm doing that is we're going to reference this same key in multiple locations. And so I'm just going to store it in a variable. So if we ever want to change it, we have to do it in one spot. So now down our preload method, I'm just going to go ahead and do this .load. And this is going to reference our loader plugin. And then what we can do is reference spreadsheet. And this is going to allow us to provide a configuration to load a sprite sheet. And what Phaser will do is going to go ahead and load in that image and then cut it up into frames based on the configuration we provide. So the first thing we need to do is our asset key. So this is going to be the key that is going to store the data into our cache. And this key is going to be used later so we can retrieve that image data from our cache. And so this key will also be used later to pull the image data from our cache. And that's how we're going to go ahead and create our game objects later. And so what we'll do is we'll do our asset key. And now we need to provide the path to where our asset is stored. And so this is going to be to our public folder here. And so we're going to have our public assets images and then our connect4 PNG. And so with our current game configuration, we don't actually have to use the public in our path. We just need to use assets. So then what we can do is we'll do images and we'll go to connect4.png. Now, because it is a sprite sheet, we need to provide our frame width and height for our configuration. And so this is going to be 32 by 32. All right, and that's all we need to do to go ahead and load in our assets. All right, so the next thing we need to do is we need to create our board layout. So for in our Connect4 game, for our board layout, we're going to represent this as a 2D array. And how this is going to work is in our game, we need to know when a player clicks on one of our columns to add a game piece, we need to know which row and column that game piece is being added to. And so in order to represent this, we're going to go ahead and loop through our columns and our rows. And so our 6 rows and our 7 columns, and we're going to create a cell for each of those positions. And basically for our cell, what we're going to do is we're going to go ahead and create a game object to have our background for where a piece can be played. And then once a player clicks on a column and we fill in that cell, we'll go ahead and add a new game object to represent that game piece that was added. And so to go ahead and do this, what we're going to do is in our main.ts file, we're going to go ahead and create a new method to go ahead and actually do this. And so what we're going to do is we're going to do this, and we're going to do create board. And then what we'll do is we're going to add this new private method. So for this method, we're not going to return anything, so we're going to set a return type to void. And so to go ahead and create our board, what we're going to go ahead and do is we're going to reference our npm package. So we need to go ahead and create an instance of our game of Connect4. So to do that, let's go ahead and add in our init method. And so we're going to go ahead and do public, we'll do init, and we'll go ahead and do void. And we want to go ahead and create our Connect4 instance. And so we're going to add a new property. So we're going to do this, we're going to do Connect4. We're going to set that equal to a new Connect4 instance. And so for our Connect4, we're going to go ahead and import that from our npm package. And then let's go ahead and add in our property. And so we'll have private, we'll have Connect4. And we're going to go ahead and set that equal to our Connect4 type. And so what this is going to do is this is going to give us our Connect4 game instance. And on that instance, we're going to have a bunch of properties to know what our game state is. And so what we're going to use right now is going to be our board. And this is going to be our 2D representation of our Connect4 board here. So what we're going to do is let's jump back down to our create board method. And we're going to go ahead and use that property. And we're going to go ahead and loop through our 2D array to create our background here. So what we'll go ahead and do is we're going to do a for loop. We're going to do let I equal 0. And we're going to do I is less than our Connect4 property. We'll grab board. We're going to go ahead and grab our first element from our array. And so this is going to be one of our rows, our first row. And so we're going to go ahead and grab the length of that. And then we're going to go ahead and increment I. And now what we'll want to do is loop through all of our columns so we can create a cell for each possible location. So we do let j equal 0. And we'll do j is less than this, our Connect4, our board. And now we're going to go ahead and do our length. So then that way we know how many columns we have in our 2D array. And then we'll go ahead and increment j. So now we want to go ahead and create our game objects. And so we're going to go ahead and create an image game object because we don't actually need to animate these. And so we're going to do this. We'll do add, and we'll do image. And now we need the position of where we want to place our objects. So for the time being, I'm just going to do 0, 0. And then we need to go ahead and add in our asset key. And so we'll use our variable for this. And now we want to use the frame that we want to add. And so with our sprite sheet, because of how it gets cut up, our first frame is going to be this red one here. So 0, 1 will be yellow, and then 2 is going to be this blue background. And so what we'll do is we're going to reference frame 2 so we can add that to our scene. All right, so before we calculate our position, let's go ahead and save. And what we should see in our scene is we should see our game objects being created. And so we can see that our game objects are very small. And so one of the things we'll need to do is we'll need to go ahead and set our scale property on this to be matched to our scale factor. And so we'll do our scale size, and that's going to double the size. And so now instead of being 32 by 32, they'll be 64 by 64 pixels. The next thing we want to do is we need to go ahead and update the origin for our game object. So by default, our origin is right in the middle of our game object, and we actually want our object to be aligned to this top corner here. So to go ahead and do that, we're going to go ahead and use our set origin method, and we're going to do provide 0 for both our x and y value. And what that's going to do is it's going to update our origin to be in our top left corner here. So now when we position our game object, we're going to use this origin to position it. So this will be right here with our 0, 0. And so one last thing we're going to do is we're going to go ahead and use the set depth property, and we're going to set that to 2. And what this does is this is kind of like the Z index for CSS. And basically it's the rendering order of how game objects will be drawn in our scene. So by default, Phaser is going to draw game objects depending on the order they're added to your scene and into the display list. So as an example, if I drew an object on top of this, we wouldn't actually see our blue game piece border here. Instead, our pixels will be overridden with whatever game object that was drawn on top of it. And so what depth does is it allows you to override that order, and it will ensure whatever the higher depth is, that game object will be drawn on top of your other game object layers. And so by default, it's going to go ahead and use 0 for all game objects. And so by providing a higher layer, we'll make sure this is drawn on top of everything else. So now that's left is we need to go ahead and calculate our X and Y position for where we want our game pieces to be positioned at. And so to go ahead and do that, we're going to go ahead and use our I and J variables here to calculate how far over and how far down we want to position each of our game objects. Because right now, we're drawing all of our game objects just right on top of each other. And so to do that calculation, we'll make 2 new variables, do const x. We're going to set that equal to I times our scale frame size. And so basically, as we're going through our iteration, we're just going to go ahead and do I times our 64. And so it's going to go ahead and do 0, 64, 128, and it's going to go ahead and repeat. So we just go ahead and update our X property. We'll see now our row is populated with all of our game pieces. So now we want to go ahead and do the same thing for our Y value, but now we want to go ahead and use J instead of I. And now what we can do is down here, we'll go ahead and pass in Y. And now we have our full game board with our background pieces. All right, so the next thing we're going to do is we're going to start working on our player input. And so for our game of Connect 4, what we need to know is we need to know which column a player is clicking on in our game in order to know where we're going to go ahead and position our game objects at. And so there are a number of different ways we could do this. We could just use our mouse coordinates position to calculate where that's at in relation to our game size. We could make each of our background game objects interactive, so that way if we click on it, we would have to figure out which column that game object is tied to and then go ahead and drop a piece there. Or what we can do is we can draw an invisible layer over top of our game board for each of our columns. Then that way, when we interact with that layer and we hover over it, we'll know which column that we're currently on. And then that way we can add game pieces in our game in that position. And so for this prototype, that's the approach we're going to go ahead and take, because we also have this nice hover effect of when we hover over our game pieces here. And so what we're going to go ahead and do is we're going to create these invisible columns so that way we can track our player input. All right, so go ahead and create our input columns. What we'll do is we'll go ahead and make a new private method, and we're going to go ahead and call that from our create method. So we're going to do create input columns. And then what we're going to go ahead and do is let's make that new private method. And so we'll do private, we'll do create input columns. And for our method, we're not going to return anything, so let's go ahead and do void. And now what we want to do is we want to loop through each of our columns in our game and go ahead and create a game object. And so we're just going to go ahead and copy this line of code here for our for loop. And now what we're going to go ahead and do is for each of our columns, we're going to go ahead and create what is a rectangle game object. And so basically a rectangle game object, it just allows us to draw a basic shape, a rectangle, based on the width, height, and our positioning that we'll provide. And then we can also do things like provide colors. And so the Phaser library has a bunch of built-in methods for building these simple game objects, and rectangle is one of them. And so what we're going to do is we're going to do const, we're going to do rectangle, we're going to set it equal to this.add, so we can reference our game object factory, and now we want to go ahead and do rectangle. So for our rectangle game object, we're going to go ahead and we need our X and Y value of where we want to position this at. So I'm just going to go ahead and do X, and we'll go ahead and do 0, and we'll update X in a second. Next, we want to know what our width of our column is going to be. And so for our width, that's just going to be our scaled frame size, because that's going to represent our game piece here. Now for our height, we want our full rectangle to take up our whole game board. So we're just going to reference our game height property here. And then next, we can go ahead and provide our color. And so what we're going to do is we're going to do 0x, and then we're going to do FF00, and that's going to go ahead and give us that yellow color that we saw in the example. Next, we're going to go ahead and do set origin, and we're going to go ahead and do 0, so that way we position it just like we did our other game pieces. And now to actually make it interactive, which is how we get access to our hover events, our click events, we need to call our set interactive method. And what that's going to do is that's going to add it to our input manager. So that way it's enabled and we can get those game events when our mouse or our keyboard interacts with those game objects. So now we need to go ahead and update our X property. And we're just going to copy this line of code here for where we calculate our X. And we'll go ahead and paste that. So now we'll see right away, once we do that, we'll see that our board now has all these yellow pieces. And what's really happening is we're drawing those 7 columns, those 7 rectangles, and it's filling up our board. And so if we go ahead and change our depth back from our background objects, we'll see here, now we have our 7 rectangles, and it just looks like there's one big yellow square. So this is why we did that set depth before, so that way our border is always visible. All right, so the next thing we're gonna do with our rectangles is we don't want it to be bright yellow like that. We're gonna go ahead and update our alpha so they're transparent. So what we're gonna do is we're gonna do 0.01, so that way they're barely visible. And we only want them to be actually visible once we hover over our game objects. So in order to listen for events, what we need to do is we need to use our on method for our game object and register the events that we want to listen for, and then that way we can provide logic that we run when those events happen. And so to go ahead and do that, we can reference our rectangle game object, we'll use our on method, and now we can provide the event we want to listen for. So we're going to do phaser, we're going to do input events, and now we want pointer over. And so this represents when our mouse hovers over a game object. And so we're going to do as a string. And now we want to go ahead and provide our callback. So this is going to be our logic that runs when this is happening. And so when this happens, we want to go ahead and update our alpha. And so I'm just going to go ahead and copy this, go ahead and paste it. And we're just going to change this to 0.2, so that way it's not as yellow. And now if we go ahead and save, what should happen is as we hover over our game objects, we can see now that our alpha is changing. And so just like pointer over, we can also listen to pointer out. And what that does is that's when your mouse leaves the game object, and we can go ahead and reset our alpha. That way it's back to our original color. So now if we hover over our game objects, we get this nice effect where it highlights and then it stops highlighting once our mouse leaves our game object. So now that we have our logic in place for our hover events, the next thing we need to do is we need a handle for when our player clicks on one of our columns in our game. So to go ahead and do this, we need to go ahead and register a new event listener for the pointer down event. And so what we're going to do is let's copy this line of code here. We're going to go ahead and paste it. Instead of pointer out, we're going to go ahead and do pointer down. And that's going to allow us to register an event listener for when we click on our game object. So what I'm going to go ahead and do is I'm just do console log click. And then what we'll do is we'll go ahead and take a look at our developer console real quick. All right, so when our scene refreshes, if we click on one of our columns, we'll see now we have our console log with our click. And so now that we're listening for our click events, what we need to do is we need a way to know which column we're actually clicking on. And so we need to add some type of unique identifier to each of our game objects that we're creating for our rectangles. And so there's a few different ways we could do this. We could use our name attribute on our game objects to give them a unique identifier. We could add some additional properties, or we can even store some additional data on our game object. And so that's what we're going to go ahead and do. So on each of our game objects in Phaser, one of the properties that we have available to us is we have this set data method. And what this allows us to do is it allows us to store any type of data we want on our game object. It's a key value store, and basically you can provide a key and a value that you want to set on it. And then later on in your game, you can go and use the get data method to go ahead and retrieve those attributes. And so this is a really good way if you want to go ahead and store any type of data you want on your game object and not worry about overwriting any additional properties that already exist from the Phaser library. And so when we use the set data method, we need to provide a key, so the unique identifier, so we can know what to reference later, and then we need to provide our value. And so for our key, we're going to go ahead and store this in a variable, and then that way we can reference it in multiple locations. And so we're just going to call this column index key. And now for our value, what we're going to do is we're going to store our index of our column. And so we'll use I for our loop. So what we'll do is let's call inside of our for loop, we'll make that new variable. So we'll do our column index key, and we're just going to call this column index. So now when we create our game object, we're storing this data. And now what we can do is when we have our click event, now we can go ahead and retrieve that data, and that way we can do something with it. So for our console log, we're going to go ahead and do our rectangle, and let's do get data. And now we'll go ahead and reference our column index key. So now if we go click on our first column, we'll see we have index 0, then we have index 1, 2, 3, and so on. All right, so now that we can click on one of our columns and we know which column we're actually clicking on, now we can connect our logic to our Connect4 library. So when we click on one of our columns, that's going to be a player taking a turn. And so we'll need to know which player's turn it is. So that way we can add a game piece of the appropriate color. And then we need to go ahead and call our make move method on our library. So in that way our player can make a move and then we can add our game piece to our game. So what we're going to want to go ahead and do is first let's grab a reference to our current player. So do const, we're going to do current player. We're going to set that equal to our connect for library. And we'll grab the player's turn. And so this will tell us which player's turn it currently is. Next, we'll want to go ahead and make our move. And so what we'll get back is a coordinate of where our game piece was added. And so we'll grab our coordinate. So this will be equal to this, connect for, make move. And so now we're going to go ahead and do our rectangle. We'll do get data. We'll do our column index key. We're just going to go ahead and type that as a number. Let's go ahead and get rid of our console log. And so now after we make a move, now we need to go ahead and add this as a game piece to our game. And so what we're going to do is we're going to make a new method to actually do that logic. So what we're going to do is let's do this. We're going to do add game piece. And for this, we're going to need to know our coordinates row and our column of where we want to add a game piece on our game board. And then we'll need to know our current player so that way we know if it's red or if it's blue. So what we'll do is we'll do our coordinate. First we'll pass in our row. Then we'll do our coordinate. We'll do our column. And now we'll do our current player. And then let's go ahead and add that method. So what we'll do is we'll do private. Let's do add game piece. We'll have our row. This is going to be a number. Column will also be a number. And then player will be a string. And then this method won't return anything. So I'm just going to do a to do. And then real quick before we do an add game piece method, what we want to do inside our on click event is first we want to make sure our game's not actually over. And if our game is over, we don't want to actually do anything. So we'll just add in that safeguard now. So we'll do this connect for. If our game is over, we'll just go ahead and return early. And that way we actually don't try to add a game piece. So now in our add game piece method, what we want to do is we need to go ahead and calculate our X and Y position based on our column and row of where we need to add in our game piece. Then we'll need to figure out which type of texture, which frame we need to use for our game piece based on if it's the first player or second player's turn. So what I'll do is let's get rid of our to do. First, we'll go ahead and do our game pieces frame. So let's make a new variable, do const, we're going to do game piece frame. And this is going to be equal to if our player string is equal to our player dot one, then we'll go ahead and use our 0 index frame. If it's player 2, we'll use our first index frame. Now for X and Y values, what we want to do is we want to take our column. We're going to go ahead and multiply that by our scale frame size. And we'll do the same thing for our Y value. So we'll do row times that by our scaled frame size. And so what we're doing here is because these are like 0, 1, 2, 3, 4, we need to go ahead and multiply that by however big our game piece is in our game so that we get the correct X and Y coordinates in our game. So now with all of our data, we can go ahead and add in our image, game objects. We'll do this.add, we'll do our image. Now let's do our X, our Y. We'll use our asset key for our connect for game. And now we'll pass in our game piece frame. So we use the appropriate game piece. All right, and then so what we'll need to do is let's go ahead and update our origin on our game object. So it's in the top left-hand corner. Let's go ahead and set our scale. And so we'll do our scale size. Then let's go ahead and set the depth. So then that way our game piece always appears on top of our game board. So we'll do set depth. We'll do 1. So now what we should be able to do is in our scene, if we click on one of our columns, we can now add game pieces and we'll see it toggles back and forth between red and yellow. So last thing we'll want to do after we add a game piece is we need to check to see if the game is over. And then if it is, we want to go ahead and display a message to the player. As for the time being, we're just going to go ahead and add a brand new method. So we'll do check for game over. Let's go ahead and add that private method. So we'll do check for game over. And so for our method, we won't have any arguments and we won't return anything. All right, so now we handled our player input. The next thing we need to do is that we need to add in our logic for when the game is over. So in our check for game over method, the first we want to do is check to see if our game is actually over. If our game is not over, we want to go ahead and just return early, so then that way we can continue playing our game. If the game is over, then we'll want to go ahead and display a message to the player about who actually won. So the first one we're going to do is we're going to check to see if this connect for is game over. If it's not game over, then we want to go ahead and just return. If the game is over, now we want to go ahead and display a message to the player about who actually won. All right, so now for our text game object, what we're going to go ahead and do is let's go ahead and we need to determine what message we need to show. So what we're going to do is we're going to make a variable to have our win text. And we're going to just set this equal to draw. And so if the players tie and there's no winner, then we'll just say draw and that no one wins the game. And then if we do have a winner, so we'll do if connect 4, we have a game winner, so if it's not undefined, then we want to go ahead and set our win text equal to player, and now we want to grab the winner, so we'll do this, our connect 4, game winner, and we'll say wins. Now what we need to do is now we actually render this out to our scene, and so we'll do this.add, we'll use the text method to create a text game object. So now we need our X and Y position, and so we'll go ahead and use our game width. We're going to divide it by 2, so that way it's centered. We'll go ahead and take our game height divided by 3, so that we come a third over the way down our screen. And now we need our text, so we'll reference our win text variable. And now we need our styling, and so we're just going to do font size, and we're going to go ahead and do 32 pixels. So then we're going to go ahead and set our origin. So we need to go ahead and set this to 0.5 so it's centered. By default, Phaser is going to place it at origin 0, so in the top left corner, and so we'll go ahead and do 0.5. So then we'll go ahead and do set depth, and we're just going to do 5, and then that way it's always above all of our other game objects in our scene, and we can always see it when we're trying to display this. So once we do that, we're also going to display a message about allowing a player to play again, and so we're just going to copy this line of code, we'll paste it. And so for this, we'll keep the same X position, but for our Y value, we're going to go ahead and divide this by 2 so that way we're halfway down. Then we're just going to adjust it a little bit, and we'll just add some 15 pixels for some padding. So now for our message, we're just going to say, click anywhere to play again. And then what we'll do is we'll keep our same origin, we'll keep their same depth. So before we test, what I'm going to do real quick is I'm just going to go ahead and switch our flag here for if the game is over, then we'll return early, otherwise we'll draw our text. So then that way we can just do one click, and we should be able to see our text game object show up in our scene. Alright, and so we just need to modify this a little bit. So for our second text line, we don't need to specify our font size. We'll just go ahead and make it smaller so we can still see it. Let's go ahead and update our Y position. So we're just going to add 30 to this so they're a little bit closer together. Much better. And so just so our text will stand out a little bit more, what we're going to go ahead and do is we're going to add a rectangle behind this, so that way it's very easy to read for the player. So what we'll do is let's make that game object. So we'll do this, we'll do add, we'll use our rectangle method to create a rectangle game object. So for our X position, we'll do 20. For our Y position, let's go ahead and do our game height. We're going to divide it by 3. And now we need our width and our height of our rectangle. So what we're going to do is we're going to take our game width. We're going to subtract 40, so we have some padding, and so there'll be some spacing between the rectangle and the sides of our canvas. And then what we'll do is we'll do our game height, and we're going to go ahead and divide it by 4. And then so for our color, we'll go ahead and do black, so we'll do 0x, 0, 0, 0, 0, 0, 0. So for our origin, we want this in the top left-hand corner, and then we'll go ahead and do set depth, and we're going to go ahead and do 4, so that way it's behind our text. Much better. Alright, so the last thing we need to do is we need to add logic to allow our player to restart the game. And so what we're going to do is we're going to allow the player to click on our rectangle, and when they do, we'll go ahead and restart the game. So what we'll do is we'll go ahead and do set interactive, so that way we can make our game object interactive. And then we need to go ahead and add an event listener. So what we'll do is we'll do once. And so this is going to allow us to listen for an event one time. And now we just want to go ahead and do our phaser, our input, our events, and we want to do our pointer down, do as string. And so when this happens, we want to go ahead and restart our current scene. And so we're just going to reference this.scene to reference our scene manager. And we'll go ahead and do restart to restart our current scene. So now let's go ahead and revert our change for check is game over. So now we can go ahead and do a quick game. So we'll see now, once someone actually wins, we can't actually click anywhere else to go ahead and add pieces. And then we go ahead and click on our rectangle. We can go ahead and restart our game. And so real quick, we're going to modify our message. So instead of click anywhere to play again, we'll say click here to play again. Alright, with that last change, that actually completes our working prototype of the game Connect 4. As I mentioned at the start of this video, the goal of this series is to create a very basic implementation of a game to get the high-level functionality of the game down with the basic game elements to make everything work, and not to complete a fully fledged game. So some ideas of how you can take this game further and really make it your own are, you could go ahead and take this and add in support for mobile, and so we can make this fully responsive instead of just being the specific canvas size here. We could have it take up our full width and height of our browser, or add some UI elements around this. And then for our touch events, you can go ahead and make sure they work on mobile. You could then go ahead and add like a title screen or a game over screen, so that way when a player arrives at your game, we'd have like a landing page, maybe some instructions on how to play, credits and things like that. You could add in a simple CPU, so then that way the player can go ahead and play against a very simple AI. You could make it complex as well. You could also then go ahead and add multiplayer support, so you actually play with other people across the web. Finally, you can go ahead and add in some animation. So then that way, when our game piece is added to our game board, we could have it appear at the top of our game and then drop down like in the real game of Connect 4. Alright, with that, that brings this video to an end. So as a reminder, there's a link in the description of the video to complete source code for this video, and as always, thank you so much for watching. I hope you enjoyed the content. If you did enjoy the video, please consider liking the video and hitting the bell icon to be notified when the next video in the series is released. For more great Phaser 3 content, please see the links on your screen now.